Hi, Bright Mind students. Welcome back to the chemistry lesson on the Engineer Squad channel. A 1-liter gas mixture consists of 60% methane gas and 40% ethane gas. If this mixture undergoes complete oxidation, determine the oxygen requirement for this reaction. To answer this question, we are going to calculate the amounts of methane and ethane gases in this mixture. Methane gas, CH4, contributes 60% of 1 liter, so its amount is 600 milliliters. Ethane gas, C2H6, makes up 40% of 1 liter, or equal to 400 milliliters. We need to write the oxidation, or combustion of these two gases. For methane gas, it reacts with gaseous oxygen to form CO2 in the gas phase, and H2O in the liquid phase. We will balance this chemical reaction. First, we check the hydrogen atoms. On the left side, the hydrogen atoms are 4, and on the right side, they are 2. Therefore, we multiply H2O by 2, so that the number of hydrogen atoms becomes 4. Next, we check the carbon atoms. On the left side, the number is 1, and on the right side, it is also 1. So, the coefficient remains 1. Finally, we will balance the oxygen atoms. On the left side, the oxygen atoms are 2, and on the right side, the amount are 2 and 2. To balance, we multiply O2 on the left side by 2. Since this equation is already balanced, we can calculate the volume of gases. In the problem, the methane amount is 600 milliliters, and we are being asked to determine the volume of oxygen. We can calculate this by using Gay-Lussac's law. It states that volume of gases are proportional to the coefficient ratio in chemical equation. Thus, the oxygen required is coefficient of oxygen divided by the methane coefficient and multiplied by 600 milliliters. Therefore, the oxygen required is 1,200 milliliters. Next, let's proceed to the second compound, the ethane. Ethane in gaseous form reacts with oxygen O2 in gaseous form, producing carbon dioxide CO2 in gaseous form and water H2O in liquid form. Before analyzing, we need to balance this reaction. First, we will check the hydrogen atoms. On the left side, there are 6 hydrogen atoms, while on the right side, there are 2 atoms. Since it is unbalanced, we need to multiply the right side by 3, making the coefficient of H2O equal to 3. Next, we check the carbon atoms. On the left side, there are 2 carbon atoms, while on the right side, there is 1 carbon atom. To balance it, we multiply CO2 by 2. Lastly, we balance the oxygen atoms. On the left side, there are 2 oxygen atoms, while on the right side, there are 2 from CO2, and multiplied by 2 from the coefficient of CO2. Additionally, there are 3 atoms from H2O, making the total 7 oxygen atoms. Thus, on the left side, we need to multiply oxygen by 7 over 2, so the oxygen coefficient becomes 7 over 2. To eliminate refraction, we can multiply all coefficients by 2, resulting in the following. The coefficient of ethane becomes 2, oxygen becomes 7, the coefficient of CO2 becomes 4, and H2O becomes 6. Next, we will input the volume of ethane, which is 400 milliliters, and calculate the volume of oxygen being required. We calculate the volume of oxygen by 7 divided by 2 and multiply by 400 milliliters, which results in 1400 milliliters. Therefore, the total volume of oxygen needed is 1200 milliliters and 1400 milliliters, or 2.6 liters of pure oxygen O2. That concludes the stoichiometry discussion for today. Please kindly support us by liking and subscribing to the Engineer Squad channel. We hope this video is useful for our understanding, and see you in the next chemistry problem discussion.